Bismillahir Rahmanir Rahim. Hello students, welcome to another video. This is Hamza Noor from Aero Education Network, and in this video I'm going to discuss a few past paper questions for International A-Level Edexcel Mechanics M1. Particularly we are covering the past paper questions for chapter number 5, Forces and Friction. Okay, so basically the concept which is based on resolving the forces and the triangle law of vector addition, where exactly two forces are acting on the particles. Okay, because when exactly two forces are acting at a point or at a particle, we can use the triangle law of vector addition as well, which is basically known as head to tail rule, or you can say nose to tail rule. Okay, the third side of the triangle becomes the resultant. Particularly based on that concept, we are covering some past paper questions in this video. And basically, I'm going to discuss the head to tail rule approach as well. And alternatively, we are going to attempt these questions by resolving the forces as well in the x direction and the y direction, respectively. Okay, meaning using the horizontal and the vertical components, respectively. So, both of these approaches are going to be discussed over here. So before actually discussing these questions in my online classes with my enrolled students, I have discussed the basic concepts of the chapter number 5, the initial concepts, which are based on exercise 5A. Okay. And those concepts are just these two things. One is triangle law of vector addition. And the second one is basically resolving forces into horizontal and vertical components. Okay. And after these questions, I have discussed the further concepts of chapter number 5, forces and frictions. So I'm basically recording the past paper question solutions in English for my YouTube channel to give the advantage to my YouTube audience as well. Okay. So first thing first, we have a question, IAL M1 January 2024, question number 4. Okay, exactly two forces are acting on a particle. So let's see what the question says. Figure 3 shows two horizontal forces P and Q acting on a particle. The angle between the direction of P and the direction of Q is 150 degrees. Okay. The angle between P and Q is an obtuse angle. Force P has magnitude x newtons. Okay. And force Q has magnitude 5 root 3 Newton. And it says that the resultant of P and Q has magnitude under root of 129 Newton. Find the value of X and find the angle between Q and the resultant, giving your answer to the nearest degree. So first thing first, I use the approach head to tail rule, which is known as nose to tail rule as well. And basically the idea behind this is that, when you have two forces, exactly two forces acting on a particle, so you just pick up one force, okay, and you place it on the head of the other force. So here I specifically picked up this force P and I kept this force P on the head of Q, okay, and then according to the vector addition law, the third side of the triangle will be this R force, which is basically the resultant of these two forces. This is known as head to tail rule. Okay, so first of all, I'm going to give you an illustration and I'm going to make this sketch from scratch. Okay, and here I will take a screenshot of the figure of the question and then we will move on to the explanations which we have already covered in the online classes. Okay, so I'm going to make this sketch from scratch over here. Okay. So basically the idea behind this is that, I'm going to pick up this P force from this point and I will place it at the head of Q, okay, in the same line of action, exactly parallel to the original force P. All right, so I will place this force P over here. Okay, and I'll make sure to make it more accurate. It looks good. All right, in the same horizontal path where the force P is ending. So yeah, it looks almost perfect. So the arrow is kept over here for force P. Okay, and now when you add these two vectors, meaning when Q plus P, according to the vector addition law, so the third side of the triangle will be the resultant force, okay, which will be the force of R, which we are looking for. Okay, so in this way, you have a complete triangle over here. This third side of the triangle is R, which is having a magnitude of under root of 129 Newton, according to the information which is provided to us in the question. Now, the main thing is to mark the angles. Okay, so basically from the point where I picked up this force P, the angle with the horizontal was 30 degrees, right? And now where I have placed this force P on the head of Q, the angle will be exactly 30 degrees over here. Exactly the same angle with the horizontal. Okay, because you know this line is parallel to this line and these two angles are equal according to the corresponding angles property. This angle and this angle must be equal according to the corresponding angles property. All right. So this is basically the idea behind this. So force P is actually having a magnitude of x newtons and we need to find the value of x. Okay. So basically this question is designed in such a way that, in order to find x, you can also find the angle which is required in part 2, the angle between Q and the resultant. Okay, so you can, by this approach, when you attempt this question completely, so you would be able to find the angle as well, which is required in part 2, and then you would be able to find the value of x as well. Okay, so this part 1 and part 2 can be attempted in a combined way. That's perfectly fine. No worries with that. Okay, so while solving part 1, first you can also fulfill the requirement of part 2 and you would be able to find the value of x according to part 1, and in the meantime you would be able to also find the angle between Q and the resultant. Okay, so basically here is a complete solution on this page. So first thing first, I marked this angle A over here. First I marked this particular angle A over here, which is like, this acute angle obviously. Okay, because inside one triangle there can be only one obtuse angle. I mean, this complete angle is 150. However, this complete angle is not 150. It is less than 150. However, this is still an obtuse angle. Okay, so basically what I'm trying to say is that first I'm going to find this angle A over here. Okay, so according to the sine rule, I can say that sine A divided by 5 root 3, because the magnitude of vector Q is 5 root 3, which is given to us in the question. This will be equal to sine 30 divided by R, meaning sine 30 divided by under root of 129. Okay, so first I'm going to find this angle A. So sine A will be equals to 5 root 3 sine 30 divided by under root of 129. So therefore, I can say that angle A is equals to sine inverse 5 root 43 over 86. I completely put this thing in calculator and I got this value 5 root 43 divided by 86. So here I found angle A to a higher degree of accuracy. I've mentioned this value. And now in order to find the required angle of part 2, okay, the angle between Q and the resultant, meaning this obtuse angle, which is below 150 degrees. Okay, this angle would be 180 minus 30 and then minus A. As simple as that. Okay, so 180 minus 30 minus A. So to the higher degree of accuracy, this angle is 127.5891, and correct to the nearest degree, this is 128 degrees. Okay, so first of all, I attempted this part 2. I found this angle. According to the requirement of part 2, the angle between this Q force and the resultant force, which is obviously an obtuse angle, which is 128 degree correct to the nearest degree. And now I can use this angle in order to, find the value of X, the magnitude of force P, because, this force P is opposite to this angle, which we have found in part 2. So that's perfectly fine if you are attempting the complete question and first in your working you solve part 2 and then you solve part 1. That is perfectly fine as well. Okay. And after this, we are going to move to an alternative approach. So in this method, we are discussing head to tail rule over here. Okay, so now I can again use sine rule. I can now again use sine rule over here. Okay, so I can say that sine 127.5891 divided by x. Okay, this will be equal to sine 30 divided by r, meaning sine 30 divided by under root of 129. Okay, so x will be equals to, put this complete thing in your calculator, which is giving you a value close, very close to an integer. Okay, x is equal to 17.99999. Okay, so when the value is very close to integer, so you just round it to the nearest integer. X is equals to 18 Newton is your answer. All right. So in this way, we have achieved complete 8 marks over here. So this was approach number 1, head to tail rule, or you can say nose to tail rule, or you can say triangle law of vector addition. All right. So x is equals to 18 Newton is your answer. Now we have an alternative approach. Okay, so for that purpose, let's move on to the next page. Alternatively, what I did is this method, resolving forces into its components, horizontal and vertical components. And obviously, we are going to get the same answer. So first of all, I took the screenshot of the picture and I brought it over here. All right. So basically, force Q is acting horizontally towards the left. However, force P is inclined at an angle of 30 degree to the horizontal. So the horizontal component is P cos 30 because this horizontal component is adjacent to this angle 30, and the vertical component is P sine 30 upwards, obviously because this is opposite to this angle 30. So P sine 30 is opposite to angle 30 and P cos 30 is adjacent to this angle 30. All right. So basically we are, first of all, we are going to find the sum of the forces acting horizontally, meaning the sigma of Fx, you can say. Okay. So P cos 30 minus 5 root 3. As we already know, the magnitude of Q force and Q force is acting towards the left. So P cos 30 minus 5 root 3. And the magnitude of P is specifically X. So in the very next step, I mentioned this thing that X cos 30 minus 5 root 3 is basically the sum of the horizontal forces. Okay. And then we are going to find the sum of the vertical forces, which is only just one component, which is P sine 30, because Q is acting horizontally towards the left. So the vertical component of this Q will be 0. Make sense? All right. So you must be well versed with all of the basic concepts before attempting any past paper questions. However, in the restricted time which I have available to record these videos, I try my best to give some basic explanations as well along with the discussion. Okay, but it's a prerequisite that you should be well versed with all of the basic concepts before attempting past paper questions. Otherwise, if you are struggling with the basics, so you know where to contact. All right. So just a shameless promotion over here. Anyways, we need to find the sum of the forces acting vertically. So P sine 30 is acting upwards. So P is specifically X, the magnitude of P is X. So X sine 30. Okay. In this way, we have found the sum of the forces acting horizontally and vertically. So this essentially means that when you consider the resultant force over here, which is under root of 129, So its horizontal component is x cos 30 minus 5 root 3, and it is acting towards the right. How do you know that this is acting towards the right? I mean, how do you know that x cos 30 would have a higher magnitude as compared to 5 root 3 Newton? It's because, when P was placed from here to the head of Q, so acting in the same path, P was over here, and the resultant force was acting like this. Okay, the third side of the triangle was the resultant. So this definitely implies the fact that, x cos 30 minus 5 root 3 would be positive. The horizontal component of the resultant force would be acting towards the right, and the vertical component would be acting upwards. Okay, and this thing will be confirmed once you find the value of x as well. Okay, so basically the horizontal component of the resultant force is x cos 30 minus 5 root 3, and the vertical component of the resultant force is x sine 30, and the resultant force is having a magnitude of under root of 129. So here we have basically a right angle triangle in which the hypotenuse is under root of 129. So under root of 129 square is equals to x cos 30 minus 5 root 3 whole squared plus x sine 30 whole squared. So I just evaluated the value of cos 30 and sine 30 respectively, and then the equation is like this: 129 is equals to root 3 over 2 into x minus 5 root 3, this is whole squared, plus half x is whole squared. So we would be able to produce a quadratic equation in terms of x, which is finally x square minus 15x minus 54 is equal to 0, which can be factorized as x plus 3 multiplied by x minus 18 is equal to 0. Since x would be positive, as the magnitude is always positive, so x is equals to minus 3 is going to be rejected, and therefore x is equals to 18 is your only answer. So the value of x is 18. Okay, as we found in the previous method as well. And now, since you are able to find the value of x, you can fulfill the other requirement, which is the requirement of part 2. Here I have, attempted this part 1 over here, and here we have attempted part 2. And in part 2, basically, the required angle was, in part 2, the required angle is the angle between Q and the resultant force, giving our answer correct to the nearest degree. Okay. So we need to find the angle between Q and the resultant force, this one, this obtuse angle. So first of all, I'm going to find this acute angle, the angle at which, this R is acting above the horizontal, anti-clockwise from the positive horizontal axis. First of all, I'm going to find this acute angle over here. And as the matter of fact is that, as you can see that, 18 cos 30 minus 5 root 3 would be a positive value. Just put this thing in your calculator. 18 cos 30 minus 5 root 3 is obviously a positive value, which is 4 root 3, which means that the horizontal component of the resultant force is positive. So it is acting towards the right, and vertical component is obviously positive. Okay, so the resultant is acting like this, as we already know this from the previous method as well, and in this method as well. So you just consider this triangle, you find this angle theta, opposite side is x sine 30, adjacent is x cos 30 minus 5 root 3. So I can use a trigonometric ratio over here by considering the opposite and adjacent sides. So tan theta is equals to opposite over adjacent, tan theta is equals to 18 sine 30 divided by 18 cos 30 minus 5 root 3. So theta is equals to tan inverse this exact value, okay, which you have evaluated by using your calculator. So theta is equals to 52.4109, okay, degrees. And therefore the required angle, which is between Q and R, this will be obtuse angle, meaning 180 degrees minus this acute angle. Okay, so 180 minus this acute angle, so 127.5891, which is 128 degrees correct to the nearest degree. So this was the alternative method which I was explaining over here. Okay. approach number two, method number two. In this way, we have attempted this question, January 2024, question number 4. So now let's move on to the next question. All right, so the next question is October 2019, question number 7. Okay, I've solved this question in only one approach over here. Okay, which is basically head to tail rule. Okay, so the question says that two forces F and G act on a particle. The force F has magnitude 4 Newton and acts in a direction with a bearing of 120 degrees, and the force G has magnitude 6 Newton and acts due north. Okay, given that P is equals to 2F plus G, find the magnitude of P and find the direction of P, giving our answer as a bearing correct to the nearest degree. So here I basically discussed head to tail rule approach and I made the sketch over here, which looks very beautiful. Okay, I'll just make this from scratch. Okay, just see the information of the question. P is equals to 2F plus G. Okay, when 2F and G are added, so this gives you P, which essentially means that vector P is the resultant of 2F and G. This also means that vector P is not the resultant of F and G. Okay, you need to understand this basic thing. Vector P is not the resultant of F and G, but vector P is the resultant of 2F and G. Okay, so first thing first, if you just observe the information given to you in the question, I'll just zoom in the picture and I'll zoom in the screen and make a sketch from scratch over here for the purpose of this recording. All right. So basically, force F has magnitude 4 Newton and acts in a direction with a bearing of 120 degree. Okay, so let's say you have a starting point over here and you make a north over here. And at a bearing of 120 degree, meaning this is measured clockwise from north. So this is an obtuse angle. Okay, so the force F would look something like this, which is having a magnitude of 4 Newton. Okay, we have marked the force F over here. And now we have another force, which is G, which is having a magnitude of 6 Newton. Okay, which is acting due north of that same point. Okay, so from the same point where we have made the north, we are going to mark the force G over here, which is having a magnitude higher than F. Okay, so this is technically the G force, which is having a magnitude of 6 Newton and it is acting exactly at north, due north, you can say. So now when we are dealing with this approach, head to tail rule. So basically, now I'm going to mark a force which is 2F, which is twice the magnitude of 4 Newton, which is twice the magnitude of F. Okay, so if anyone sees my sketch which I'm making, so I will place the 2F force on the start on the head of the vector G. Okay, and here I am going to mark this 2F force, which is having technically a higher magnitude as compared to the vector F. So let's say this vector is 2F. And basically P is the resultant of 2F and G, meaning G plus 2F, or you can say 2F plus G, same thing, right? Either you say P is equals to 2F plus G, or you say P is equals to G plus 2F, the same thing. Okay, so now the third side of the triangle will be the resultant force. Okay, and here is the resultant force which we are looking for, which is the resultant of 2F and G, not F and G. Okay, so here is basically the force P. In this simple way, we are going to make this diagram over here. Now the thing is how to mark the angles. The technique which is used to mark the angles over here. So basically from the point where I picked up this force F, okay, and I increased its magnitude to 2F, okay, I increased its magnitude to 8 Newton, and I placed this 2F force at the head of the G force. All right. So originally where the force F was acting, it was making an angle of 120 degree with the north, the obtuse angle. Okay, and to the point where I have placed this 2F force, I'm going to make a vertical broken line over here, and this obtuse angle would be 120 degrees. This makes sense or not? Very simple. All right, I have picked up this force F and increased its magnitude, and angle at this point was 120 degree, the obtuse angle from the north, the bearing of 120. So obviously this would have the same bearing over here of 120 degrees. This makes sense. So inside the triangle, this acute angle would be 180 minus 120, which is 60 degrees. Perfect. Okay, so now you have a triangle something like this. All right, that this side is 6, this side is 2F, which is 8, this side is P, and the angle between 6 and 8 is 60 degrees. All right, so now you can use the cosine rule in order to find the value of P. As simple as that. So this is basically the technique by which you are going to make this sketch, and I have already made this sketch over here, and I'll discuss the working completely now, and I'll just erase this. I just made this sketch from scratch for the purpose of this recording for my YouTube audience. Okay, so this is basically the idea. Now I'm going to enlarge the picture of the question over here. So I hope you understand what I am trying to convey. So P is equals to 2F plus G, or you can say P is equals to G plus 2F. Same thing. Okay, so we have a triangle in which the third side is P. This length is 6, this is 8, and the included angle between 6 and 8 is 60 degrees. So we can perfectly use the cosine rule. So P square is equals to 6 square plus 8 square minus 2 times 6 times 8 multiplied by cos 60. So P square is equals to 52 Newton, meaning P is equals to under root of 52, which is 7.21 Newton, correct to three significant figures. In M1, you can write your non-exact answers correct to 3SF or 2SF. Edexcel M1 mechanics, which we are discussing. All right. So this was a requirement of part one. And as far as the part two is concerned, okay, in part two, we need to find the direction of P, and we need to give our answer as a bearing correct to the nearest degree. Okay, so first of all, what I'm going to do, I'm going to find this angle X over here. Okay, and obviously once I am able to find this angle X, I would be able to tell the bearing. As simple as that. So I can use the sine rule over here. So sine X divided by 8 is equals to sine 60 divided by P. And in my further calculations, in order to avoid any premature approximations, I will use the exact value of P in my further calculations. So exact value of P will be used under root 52. So sine X is equals to 8 sine 60 divided by square root of 52. So this means X is equals to sine inverse 2 root 39 divided by 13. So first of all, I found the value of X to a higher degree of accuracy, higher state of accuracy, and then I gave my answer as a bearing correct to the nearest degree in a three-figure number. Okay, it's a usual practice to write the bearing as a three-figure number, but sometimes if you forget to write as a three-figure number, then that's also perfectly fine. No worries with that. However, it's a usual practice to write the bearing as a three-figure number. So this is your answer to part two. All right. So this was basically the head to tail rule approach, the only approach by which I discuss this particular question in my online class. Alternatively, we can also discuss this question by the method of resolving forces. Okay, and for that purpose, I don't have a space on the next page. On the next page, I have the next question. So I'll make a space on the previous page. Okay, I'll just completely erase this working, which is already discussed for this recording, and I'll bring the screenshot of the question over here. Okay, so we are going to do this by the alternative approach. Okay, and I'm going to solve this on this page from scratch. All right, and we are going to get the same answer over here. So first thing first, what we know the fact is that we have a point and we make a north at that point. Okay, and force F is actually having a magnitude of 4 Newton, which is acting at a bearing of 120 degrees. Okay, this F is having a magnitude of 4 Newton, and G is acting due north. Okay, so G is having a magnitude of 6 Newton and it is acting due north, meaning force G is acting vertically upwards, 6 Newton. So here I'm going to paste the screenshot. Okay, I'll just enlarge the picture. All right. So basically what you need to understand is that we are, considering the 2F force, okay, not the F force. So I'm going to just extend this F force. I'm going to make its magnitude look twice the original force. Let's say something like this. This is basically the 2F force, which is having a magnitude of 8 Newton. And obviously this is acting at the same angle 120 degrees. Okay. So basically, first of all, we are going to find the sum of the horizontal forces. So sum of the forces acting horizontally. Okay. And I'm going to make a horizontal broken line over here. And since horizontal and vertical are exactly perpendicular to each other, so this acute angle, which is acting below the horizontal, would be 30 degrees. Okay. This angle would be 30 degrees, as simple as that. All right. So from 120 degrees, you are going to subtract 90 degrees. Okay. So basically, this horizontal component would be 2F cos 30 towards the right, and the vertical component would be 2F sine 30 downwards. All right. So when you are finding the sum of the horizontal forces, so there is only one force which is acting horizontally, and it's equals to 2F cos 30. And since we know the magnitude of F, so 2 times 4 times cos 30. So 8 cos 30 is basically the horizontal component, meaning the sum of the horizontal forces. Okay, so the value of 8 cos 30 is supposed to be 4 root 3 Newton. 4 root 3. And now we are going to find the sum of the forces acting vertically. So G is acting upwards and 2F sine 30 is acting downwards. So G minus 2F sine 30. Okay, and G is 6 Newton and minus 2 times 4 times sine 30. Okay, so 6 minus 8 sine 30. This will give us a value 2 Newton. Okay, so far we have found that the sum of the horizontal forces is also positive and the vertical forces sum is also positive. So this definitely implies the fact that the resultant of 2F and G, which is P force itself, it is having a horizontal component of 4 root 3 Newton acting towards the right. Okay, and vertical component of 2 Newton, which is acting upwards. Okay, 4 root 3 towards right and 2 Newton upwards. And basically Here is the force P which we are looking for. Now, in order to find the magnitude of P, we can just use P square is equals to 4 root 3 squared plus 2 squared. So just put this thing in your calculator. 4 root 3 whole squared plus 2 squared. Okay, so this is supposed to be 52. Therefore, P is equals to square root of 52. Okay, and square root of 52 correct to 3 SF is 7.21 Newton, the same value which we obtained from the previous method. Okay, and in my further calculations, I am going to use the exact value of P. All right, in this way, we have attempted this part one over here. Now, as far as part two is concerned, so we need to find the direction of P and we need to give our answer as a bearing correct to the nearest degree. So first of all, what I'm going to do is I'm going to find the angle with the horizontal over here. Let's say I'm going to mark this angle theta. So I can say that, tan theta is equals to opposite over adjacent, meaning 2 divided by 4 root 3. Alternatively, I can use sine theta and cos theta as well by considering the hypotenuse P. So cos theta is equals to adjacent over hypotenuse and sine theta is equals to opposite over hypotenuse. That is also perfectly fine. Okay, so theta is equals to tan inverse 2 divided by 4 root 3. Okay, so tan inverse 2 divided by 4 root 3. This is supposed to be 16.1021. I'm going to write this value to a higher degree of accuracy. 16.1021 degrees. Okay. And now, as far the required angle is concerned, I need to find this as a bearing. Okay, I need to find the bearing of this force P. So I'm going to make a north at the starting point and I'm going to find this angle as a bearing. So perfectly fine. I'm going to find this angle in clockwise direction. Okay, so the required angle, I mean the bearing which is required, you can say that the required bearing which we are going to find is supposed to be 90 minus 16.1021. So 90 minus 16.1021, which is 73.8979. 73.8979 degrees and correct to the nearest degree 74 degrees, and as a bearing the usual practice is to write the answer correct to three-figure number, answer as a three-figure number. So bearing is 074 correct to the nearest degree. All right, so this was the complete alternative approach. Okay, and for the purpose of this recording I have discussed this approach from scratch. So I hope you understand this. All right. In my online class, I only discussed the head to tail rule approach for this particular question because I thought, uh, the students can do this approach on their own. So comparatively, a more technical approach was head to tail rule. So I gave importance to head to tail rule in the class. Okay. And now we have one last question left for this recording. So let's discuss this one as well. This one is June 2017, question number 7. Okay, so two forces P and Q. Two forces P and Q act on a particle. The force P has magnitude 8 Newton and the force Q has magnitude 5 Newton. The angle between the directions of P and Q is 50 degrees as shown in figure 3, and the resultant of P and Q is the force R. Okay, the requirement of part A is to find correct to 3SF the magnitude of R. Okay, so first I used head to tail rule approach over here. Okay, and I basically picked up this force P. All right, and I placed it on the head of force Q. And the third side of the triangle would be the resultant according to Vector's law of addition. Okay, so I believe that making this sketch from scratch would not be required over here. Okay, we have already discussed in the above two questions, and I hope you have covered all the basic concepts. Okay, so anyways, from the point where I picked up this force P, it was having an acute angle with the horizontal 50 degrees, meaning the angle which was above the horizontal. So obviously I'll make a horizontal broken line over here, and this acute angle would also be 50 degrees. So inside the triangle, this angle would be an obtuse angle, which is 130 degrees. So here we have a closed triangle, okay, in which the third side of the triangle is the R force, which is the resultant, okay, and P is having a magnitude of 8 Newton, as we already know this. P is having a magnitude of 8 Newton and Q is having a magnitude of 5 Newton. Okay, and the angle between P and Q is 130 degrees. So we can simply just use the cosine rule over here. So R square is equals to 8 square plus 5 square minus 2 times 8 times 5 multiplied by cos 130. So R square is equals to 140.4230. So R is equals to square root of this value, square root of this value. So R is equals to 11.8500. So therefore R is equals to 11.9 Newton. Correct to three significant figures. Okay, this was the working for part A. Alternatively, we can do this by the other approach, which is done on the very next page. Okay, so I'll discuss with that approach as well. In part B, we need to find to the nearest degree the size of the angle between the direction of P and the direction of R. Okay, we need to find the angle between P and R, this one. All right, we need to find this angle over here. And for that purpose, first of all, I'm going to find this angle which is inside this triangle, which is basically angle X over here, which I've marked over here. Okay, so I can just simply use a sine rule. So I can say that sine X divided by P, meaning sine X divided by 8 is equals to sine 130 divided by R. And the value of R I have chosen correct to a higher degree of accuracy in order to avoid premature approximations in my calculation. So sine X is equals to 8 sine 130 divided by R. Okay, and here is the higher degree of accuracy, R value. So sine X is equals to 0.517161. 0.517161. So X is equals to sine inverse 0.517161. So X is equals to 31.142 degrees. Okay, and the required angle which we are looking for, so from this 50 degrees, we are going to subtract this angle X, which we have found. So the required angle is supposed to be 50 minus 31.142, which is 18.858, which is 19 degree correct to the nearest degree. We were required to find the angle correct to the nearest degree. So this is supposed to be your answer. This was basically head to tail rule approach, or you can say nose to tail rule approach. All right. So alternatively, I have discussed this question by the alternative approach, which is resolving forces. Okay. So I basically brought the screenshot of this figure over here. I enlarged the picture. So P is inclined at an angle of 50 degree to the horizontal. So the horizontal component of P is P cos 50, which is acting towards the right, and the vertical component of P is P sine 50, which is acting upwards. So P sine 50 is opposite to the angle 50 and P cos 50 is adjacent to the angle 50. And Q is itself horizontally acting towards the right. So therefore I can say that the sum of the forces acting horizontally would be Q plus P cos 50. Makes sense? Q plus P cos 50, meaning 5 plus 8 cos 50. All right. So The sum of the horizontal forces is 5 plus 8 cos 50, and sum of the vertical forces, there is only one vertical force which is acting upwards, which is P sine 50, and the magnitude of P is given to us 8, so 8 sine 50. So basically I have made a triangle over here, which is a right angle triangle. Okay, the adjacent side is 5 plus 8 cos 50, opposite side is 8 sine 50, and R is basically the hypotenuse. So R square is equals to 5 plus 8 cos 50 whole square plus 8 sine 50 whole square. So R square is equals to 140.4230, and after taking the square root, after taking the square root, we are obtaining the same value which we obtained in the earlier calculation, and correct to 3SF. I have mentioned the value of the resultant magnitude, the magnitude of the resultant. And then we are required to do the part B as well. So basically, I brought the screenshot over here of the figure, and I marked the forces like this just to, illustrate the fact that, the horizontal component of the R force, the horizontal component of the resultant force is 5 plus 8 cos 50, and the vertical component of the resultant force is 8 sine 50. Okay, so what I need you to understand is that, what is 5 and what is 8? 5 was basically the magnitude of Q, and 8 was the magnitude of P. Okay, P is equals to 8, P was equals to 8, and Q was equals to 5 as per the information of the question. So what I need you to understand is that, since Q is 5, Q is acting horizontally, okay, and we have a horizontal component which is 5 plus 8 cos 50. So, obviously 5 plus 8 cos 50 is higher in magnitude as compared to 5. This makes sense, right? So obviously, the length of the horizontal component of the resultant force would have a higher value as compared to Q itself. So for that purpose, I have extended this line over here like this. This makes sense or not? Because in Q, in 5, we are adding 8 cos 50. Okay. And since, there is only one vertical component over here, which is basically P sine 50, or you can say 8 sine 50. So whatever the length of the vertical component of P would be, it would have the same length as 8 sine 50 over here. Make sense or not? This definitely implies the fact that, that this force, R force, is acting at an angle which is below 50 degrees. Whatever the angle over here will come, it is obviously below 50 degrees. This makes sense or not? We can say this thing with a surety that whatever the angle theta would be over here, it would be below 50 degrees. This makes sense according to this sketch. Because, P sine 50 and 8 sine 50 are the same thing, right? So basically the magnitude of the vertical component of P would be the same as the magnitude of the vertical component of R. However, the magnitude of the horizontal component of the resultant force would be greater in magnitude as compared to force Q itself, because force Q is acting horizontally. So I'm just trying to establish the fact that, this angle over here, theta, would definitely be below 50 degrees. It cannot be exactly equal to 50, and it cannot be more than 50. Okay, so you need to understand this basic thing. So you just consider this triangle and opposite over adjacent. So tan theta is equals to opposite over adjacent. So tan inverse 8 sine 50 divided by 5 plus 8 cos 50. So this angle theta is 31.142 degrees, which is definitely below 50 degrees. All right. And therefore, the required angle which we are looking for, we need to find the angle between P and R, right? This angle. Okay, so 50 minus 31.142, which is 18.858 degrees. 18.858, and correct to the nearest degree, we have mentioned the value, which is 19 degrees. Okay, so this was basically the alternative approach which I have discussed over here. All right, so for the purpose of this recording, for the sake of this recording, I have discussed these three past paper questions. Okay, and these are those questions in which exactly two forces are being acted on a particle or at a point. All right. So inshallah, I'll be uploading more content. Stay tuned to my channel. Thanks for watching. Assalamu alaikum.